So welcome. Today I'm going to talk about the publication of environmental data through SIOS. I'm Luke. I chair the SIOS Data Management Working Group at the moment and have done for the last 2 years. That's as part of my role at UNIS, where I've been working since 2020. But now I only have a 20% role there because I work most of the time at the Norwegian Meteorological Institute. A quick recap on where we were from the last few presentations. This is a representation of all the data centers that contribute to SIOS. You can see them in these red triangles. And my idea of SIOS is that we don't host any data ourselves, but we provide a single searchable catalog of all the metadata directing you to those data. And you can download data directly from the SIOS catalog. So the idea being that we're all from different areas of the world, but collecting data that are relevant to Svalbard. And the user should be able to come and access the data in a single place, rather than having to look through all of these different data centers to find data that might be useful to them. SIOS is one of many catalogs that exist. They all rely on interoperability between these data centers and common standards, so that we can use some software that we develop to link SIOS to, for example, the Polar Institute's data center, and we can reuse that same software to connect SIOS to all the other data centers as well. I should start by saying, what do I mean by environmental data? Well, this can be any measurements of the physical environment. And of course, environmental data is a wide range of different things, from measurements we get from satellites down to all kinds of land-based instruments, and even down to someone writing numbers in a notepad in the field and then uploading them later. And part of the challenge is that for a data user, you might be interested in a lot of these different types of data, but often different types of data from different instruments and different sources have their own kind of proprietary data formats. And if you really want to access these data, this might create kind of a wall for you where you don't feel like the data are really very accessible to you. That this is impeding you from accessing them. You have to learn a new standard every time that you want to access a new kind of data. So the challenge is here that with all of this wide range of environmental data, is that we need to have some kind of common language for encoding all this data. Some way that if you are familiar with this common language, that you should be able to access any of the data in exactly the same way without having to learn some new software or some new standard. So if we want to make these data available to anyone who's interested in them, we need to first be able to combine and subset data sets together. People are more likely to be interested in, for example, all the seawater temperature data from an area around Svalbard, instead of data from individual data sets like all the data from an individual cruise. People need to be able to download the data in their choice of format. If I asked everyone here what format they prefer to work with, I'd probably get a range of answers. So it's good to be able to allow people to have that flexibility. And we also need to be able to simplify things that people want to do with the data. So visualizing the data, analyzing them, processing them. This all relies on software that can do this, either software you download or software that's on the fly on the web portal. And that software needs to be able to understand the data that it's working with, obviously. This brings me to the issue with a lot of data that we see published today are often in some kind of tabular format, might be Excel, CSV, something like this. And they usually not really got any defined structure. It's difficult to understand exactly what X might be, but even if you're looking at something like temperature, is this the air temperature? Is this the sea temperature? What depth are those measurements taken at? So whilst some of this might be understandable to a human and to the person who's maybe created the data set, there's some ambiguity, and it's not necessary. You shouldn't assume that everyone is going to be able to understand the data in the same way. And that's why standards are useful. So we talk about having interoperable data formats. Interoperable means that you should be able to take the data and apply it in not just one piece of software, but also open it in a second piece of software and a third piece of software, and it should behave in all of them in exactly the same way. And equally, similar data sets should all be openable and usable in the same software. This relies on having a standardized structure for data, so that the data and the metadata are always in the same place. We know where to look. The metadata ideally need to be included within the file, or at least be some link to the metadata from a data file. This is useful because it allows people to understand everything that's meant by the data without having to contact the data provider themselves. Those data need to be taken from controlled vocabularies, the metadata terms. A controlled vocabulary is like a glossary of terms where you have a description and a defined name for a term that you should use. And it should be available on the internet with some identifier unique to that as well. So that if you're creating a data set and you've selected this term and you've read this description, someone on the other side using the data can also find this term and read this description, and you have some common understanding of what is meant by those data. The format needs to be software independent. It shouldn't be some software dedicated format that has been developed. And it's all well and good having standards and vocabularies, but that's only really useful if these are well documented and maintained. So it's good to go for established standards where you could see that there's been activity and constant development of this, and it's likely that that standard is going to exist in the future. And all of this together makes the data machine readable. So I'm going to propose a few standards that we recommend for SIOS. The CF-NetCDF, I'm going to talk a lot about this today. And these are for measurements of the physical environment. It could be time series of data, vertical profiles, trajectories, maybe you have multiple dimensions or map data, something like this. Anything where you can fit your data on some kind of grid in space and time. It doesn't have to just be measurements of the environment themselves. This could be some output from models. So climate models are often using CF-NetCDF as their format. Could be other formats like point clouds, digital elevation models, satellite data. We're starting to see a movement towards this as well. And there's even been some niche case studies where I've helped people do things like flow cytometry data and sedimentary logs, I think would potentially be included in this. This is basically just a vertical profile of numbers. So potentially this is a suitable format that we could use where there isn't a format already really for this. The other format that we're recommending at SIOS, at least for the SIOS core data, is Darwin Core Archive. And this is mainly used for biodiversity data, or has been developed originally for biodiversity data. But you can also publish a lot of other data in this now, as this has been expanded to encompass any measurements or information related to those specimens. I'm not going to talk very much about this. That's what the next webinar will be on, given by Dag Andersen from GBIF Norway. That's in a few weeks' time. And I should just say, SIOS doesn't discriminate between data formats. Any data format can be made available through the SIOS catalog. These are the formats we're recommending for SIOS core data, so it has to be in these formats, and these are the formats that we're open to building services for at the moment. There are other formats, and I'd like to talk about where we are with this. Firstly, I hear a lot of people talking about open formats, An open isn't the same as interoperable. You need some standardized structure. So people often say, can't I just use JSON or XML? And there's nothing wrong with them as a file format, but there needs to be some structure within that to make that standardized. There's other formats that you have where there's a consistent structure, but there's not really a standard, and there's perhaps insufficient metadata within them to make them really describable and usable. So this might be things like PLY or LAS files for point clouds. It might be basically any data set you get from an instrument where you're always getting the same file every time you use that instrument, but that is not necessarily interoperable with other standards. And even a NetCDF file, if you're not using conventions within this, the CF conventions, this is just an object with some structure, but is not interoperable. And there's other cases where there's a lot of global initiatives to improve existing standards, but we're not currently good enough for us to recommend for SIOS core data. There might be cases where we would recommend some of these for your data. You can talk to us at SIOS on a case-by-case basis if you're considering some of these formats. But this might be something like GeoJSON, GeoTIFF, GeoSAR, Camel, which is for snow profiles. There's a lot of work going on within this. I would like to think that in a few years, when I do a repeat of this presentation, that we'll be able to talk more about some of these formats as they've got to the case where we can consider them fully interoperable with the other standards. So we're getting there, and there's a lot of work going on. There is an advantage of fewer standards. Often when you see a gap in standards, people think, oh, I'm just going to develop my own standard for this type of data because my data don't really fit with that standard. And the issue is with discipline-specific standards is that ideally it's better if there's fewer standards for people to learn. It's easier to share data between disciplines if every discipline is using a subset of the same standards. And also, it's more efficient for people who are working with the data and building software and services on top of them if we have fewer standards to work with. It's just not practical for us to support hundreds of different data formats. So let's talk about NetCDF. If you've never seen a NetCDF file before, this is what they look like. It can be a bit daunting if you've never looked at them before, so I'll guide you through this. So you have some dimensions in this test example that I created. You can see that this tells you that there are potentially 2 points of time, 3 points of latitude, and 4 points of longitude. This tells you about the shape of the variables and the size of them, but it doesn't actually tell you anything in the dimensions about the values themselves. That's stored in the variables. So you have this latitude variable here. That's the name of the latitude of the variable. It's in float format. And in brackets, you can see the name of the dimension, which is also latitude. And it's quite common for variables to have the same name, the coordinate variables to have the same name as their associated dimension. It's common, but it's not mandatory. And then you also have data variables, which might have more than one dimension. So this is the sea surface skin temperature, and we see this is a 3-dimensional array with time, latitude, and longitude as dimensions. So this is one advantage of NetCDF over some tabular formats, that you can store multiple dimensional data in multidimensional arrays. And you can't really do that. You're kind of confined to one dimension with CSV, or apart from with some kind of workarounds. Alongside that, you have the variable attributes, metadata describing each variable. And you also have the global attributes as well. So these are the attributes describing the data set as a whole. So things like the title, some summary, who created the data set, where they're published, the license, and so on. Perhaps most important is the conventions used. So we have, in this case, the climate and forecast conventions, CF, and the attribute convention for data discovery, ACDD. And I will go into these now. So the attribute convention for data discovery, as the name suggests, is providing discovery metadata. So metadata that helps someone find a file. So if you think about a search interface, the discovery metadata is the metadata that each element in that catalog needs to have in order to make it findable. And ideally, you need to have consistency between discovery metadata, between different data sets, in order to make that search catalog really useful. So ACDD has a range of different attributes that you can go and pick from, and some are highly recommended, or optional below. There's a bit of a problem with this. Firstly, recommendations aren't the best way to enforce consistency between data sets. It's better if they have some requirements, or at least some minimum requirements. And the second thing is that ACDD hasn't really been supported very much. This version is something like 10 years old now. There's a lot of discussion about who's going to take this on and improve this. There's some degrees of freedom in how you're supposed to fill this in that should be narrowed down, and some things that aren't really covered. So for SIOS, what I would recommend is that you instead use the recommendations of the Arctic Data Center. So this has been updated recently by Lara Farigi, who works here at the Norwegian Met Institute. And whilst these are on the Arctic Data Center page, these are also the recommendations of SIOS. If we're supposed to have a searchable catalog working across all of the data centers, we need to start having common standards for how we're including those metadata, and a common set of requirements as well. So I would like it if these standards were also visible on the SIOS page. Hopefully that will happen in the future. But for now, you can go to the Arctic Data Center page and see those. A little bit of an explanation of what you find here. There's a list of all the different terms and descriptions of how you should fill them in. You can also see which terms are required. They're shaded as well as been labeled as required. People tend to like to see examples of how to fill in each term. I think this is really useful. So there's a full list of examples for every single term and how to fill this in. And there's also a minimum set of examples. So the minimum requirements if you want to publish data with Arctic Data Center, and how to fill in each of these attributes. So this is discovery metadata that helps you find the data, but this doesn't necessarily help you use the data. And this is where CF comes in, and the use metadata. So the climate and forecast conventions are a community-driven set of metadata conventions. This is a picture we took a few years ago at the workshop in Sweden. You can see me here. I'm part of the CF Conventions Committee. We meet about once every few months to discuss different things. Not many of us have any direct funding to do this, so we really rely on people's goodwill and contributions. This is a nice community of people who are trying to make things better, and a lot of work is reliant on this. And if you want to get involved, that's a nice thing to be able to do. They were designed originally for NetCDF, but they are metadata standards that should not be specific to NetCDF, and we are considering how to expand these to other formats. This is kind of started without the CF convention's blessing, if you like. A lot of different formats are now taking on CF metadata and encoding it within their data formats and standards. This is a good thing. It's nice to use a common set of metadata conventions for different standards. But at the moment, we're kind of struggling with being able to update the conventions documentation to represent all of these different formats. And this is a bit of a challenge that we have to figure out. And then we can really say that, okay, this JSON file is CF compliant, for example. But good that people are taking this on. This is the CF metadata conventions homepage. There's a few things I'll show you how to get to. You can view the latest release at the top. It's a long document, something like 300 pages. You don't have to read all of that to know how to use the conventions. You can use this a bit like you would an encyclopedia. So you find the section that is relevant to what you're doing. So if you, for example, have a latitude coordinate within your file, there's an example here of how the minimum requirements of what metadata you should be including with that latitude coordinate, and some explanations as well. Really interesting is different feature types. So we have these annotated examples of discrete geometries for time series of data, vertical profiles, trajectories, points. This could be an individual point. It could also be a point cloud or a random series of points in time and space, and time series of profiles and trajectory of profiles. So you can see one of these examples here for a vertical profile, and you have this attribute that you're required to include here, this feature type profile. And this tells someone working with the data that this is a vertical profile of data. And we use this at SIOS in order to build visualization and later aggregation on top of this. So if you create a NetCDF file and you have a vertical profile of data, maybe a CTD profile or something, and you encode this, it gives you an example of how to encode all your variables, include this feature type profile, then we can do some really interesting stuff with the data, which I'll show you soon. There's a full list of different attributes you can include. So as I said, these obey with the kind of minimum requirements, but in some case you might want to do some different things. I don't have time to go through all of this right now, but just know that if you have some information you want to encode, this is a good place to look before you start adding your own custom attributes. And these again are the different feature types that we have. So I've gone through this previously, but these are summarized here on this part of the document. So an example of what we're doing with SIOS, this is some SIOS core data, which if you didn't attend the previous one is time series of data where we have a time commitment of at least 5 years to continuously provide data. And some of these time series are much longer than this, like this one dating back to 2011. So this is a weather station at Hopen. Remember that we're not hosting any data at SIOS. These data are stored at their contributing data center, but we're able to provide this visualization on the SIOS webpage. So these data are in NetCDF. They have the time series feature type attributes. And you can do things like select different data variables that you want to view. You could resample the data on the fly as well. So this is looking at now weekly values. You can zoom in and have a look at the data, only the data you're interested in. And you can also export the data. You can choose which variables you want to export if you're not interested in everything. You can export the raw data or how you have resampled them. You can specify the date range you want to export. And you can also specify the data format. So whilst these data are in a NetCDF file, you have the option of downloading these into CSV. So this is a really nice example of where maybe you're not comfortable with working with NetCDF, but if you invest a bit of time in encoding the data in this way, people using the data later can access them in a range of different formats. And I'm sure this list will expand through time as we develop things further. And this is, as I mentioned, this is a SIOS core data set, but it's not only SIOS core data that we're providing these services on top of. Any data that you have stored in NetCDF, if you have this feature type attribute and everything is compliant with CF, and if you're serving the data using OPeNDAP, which allows us to stream the data over the internet, more on that in a bit, then we can provide this service on top of the data. Just a few other examples. We also are offering this for profiles of data. This is a CTD profile from the UNIS hydrographic database. This is a collection of something like 70,000 CTD profiles dating back for, I think, more than 100 years or something now, all around Svalbard. And this should be available for all of those. So go and find that data set if you're interested in this kind of data and access all of this. There's a lot of time series profile data from several permafrost stations that we have over Svalbard. So a time series profile, we have both the depth and time dimensions. So here we're looking at a vertical profile of data at some time, and you can toggle through this time series to look at the different depth profiles at different times. Or you can switch between these points here and start looking at, for example, a time series of data at a certain depth and toggle between those depths. Something coming soon is trajectory data. So this is where you have an instrument that's moving through time. And in this case, this blue point here corresponds to this red line on this time series. And you can move through the date slider and see where the point moves along this line. And as this red line will move across the time series as well. And then you can read off the different values that you're interested in. So this is in progress. Hopefully we can launch this in operation in the next few months. As I mentioned, this is all possible because of OPeNDAP. So not all data centers contributing to SIOS are supporting this at the moment, but those that are, if you publish your data in NetCDF and say you want them available via OPeNDAP, you'll get some access URL that you can see here, this data URL. And what you can do is you can take this into your Python or MATLAB or R code and work with it in exactly the same way that you would some file path on your computer. So it will allow you to stream data over the internet without having to download the data first. That's nice for a few reasons. Firstly, if everyone is downloading data sets, and particularly if those data sets are large, that might be impractical and kind of not particularly environmentally friendly either. But the other nice advantage with this is that if this is a time series of data where you are appending data to this through time, or someone is appending data to this data set through time, let's say this is a weather station, and you want to have some plot at your institute to see what the latest weather data is showing, you can just use this data URL and set some job up to run, let's say, every hour or every minute or whatever. And it can continuously run and update as new data are appended to the data set. So that's really nice. This is probably a good place to talk about granularity. So this is kind of a data kind of word, but basically it means finer granularity means you've got more files, more detail, whereas coarse granularity might mean that you have a more data within a single file. So these dots here might be CTD profiles, whereas this blue polygon might be all the CTD profiles from a single cruise in a single data set. So at SIOS, we would recommend that you go with the finer granularity option of providing individual stations in individual files. You can gather them in a collection afterwards if you want to have everything together and provide the context. But ideally, each should be treated as its own data set in its own file. This allows us to provide more descriptive metadata. You can see this just from the plot. It's difficult to see within this polygon exactly which points have been sampled, which is not particularly useful if you're only interested in a subset of this area. You can imagine the same would be true if you're interested in only data from a small time window and someone has published years worth of data in a single file. It's nice to have the metadata at a finer granularity. So this makes it easier to find data, as I've suggested. And it's also much better for machines. And this just comes down to the degrees of freedom. If you have a single profile, it's very easy. You only have a single dimension, and then each of the variables are one-dimensional arrays. If you start having multiple profiles, you need to have 4 dimensions. You need to have, well, at least 2 dimensions, time and depth. You have to have some way of encoding the latitude and longitude, and different people have done this in different ways. So we kind of increase the degrees of freedom, and this ultimately reduces the interoperability of the data. One more thing I'd like to point out on this page, the CF conventions, is the standard names. So this is a vocabulary of parameters, basically, and it's searchable. So you can search for the soil moisture here, and you can look through and read all the descriptions related to that. If you don't find what you're looking for, most of this development happens on the CF Convention's GitHub page. There is a few different things, but if you go to the vocabularies repository, you can suggest new standard names to be added. If you don't want to do this yourself, talk to someone in SIOS or your data management representative and ask them to do this for you. It's nice for the data management community to work as a middle person between the conventions and the scientific community. There's different tools that we have for working with these data. One that I'd like to point out now is this Nansen Legacy template generator that I developed alongside Olaf Schneider at the Polar Institute. So we acknowledge that even though we want people to work with NetCDF, that might have a bit of a learning curve for some people, and people are still going to want to record data in spreadsheets. But what this allows you to do is create a CF compliant or a CF considering spreadsheet, let's say, where you can select the different coordinate variables, and you can also add different standard names. And then this is a full list of standard names searchable here. You can add them as your fields, generate your spreadsheet, and you have one column for each of the variables that you want to add. We then have a separate sheet for the variable attributes, so you can enter the metadata alongside this, and it tells you which columns or which rows are required and which ones are optional. Some of them are filled in for you, like the standard name. And there's global attributes here as well. And again, we have the requirements and the optional variables here. Another tool, Rosetta, which is developed by some people at NERSC mainly. And this allows you to convert data in some tabular format, so maybe CSV or maybe well-behaving Excel file into NetCDF format. So in this case, you choose what your feature type is. If you have a time series of data, a profile, a trajectory, it matters a bit less to look at these pictures and the actual descriptions. What is important here is you're selecting the correct thing in brackets. You can upload your file, and then you can work through this as a form and fill in the different things. I don't have time to go through all of this now, but it's nice to have a user interface to guide you through this process. There's a lot of other support and online material that we have available. You can find this on the SIOS page under Data and Support and Online Materials. This is where you can find different workshops that are coming up and different online documents that we have to help you out. Some things that I developed is this NetCDF in Python course. You can learn how to open NetCDF files, create plots, create NetCDF files, and so on. So you can have a look at this. If you prefer to work with R, there is an R equivalent of this. And if you are wanting to make your data CF compliant and ACDD compliant, you better be making sure that you're actually checking that it is. So SIOS also hosts a validation service where you can take a file up to a maximum size of 1.5 gigabytes approximately. You can say which convention you want to compare this against and upload it and hit validate. And you'll get some different helpful messages on if it's compliant and if it's not, what errors you might need to fix before you try again. So just to conclude, are these SDMS data available to anyone who's curious today? Well, no, they're not. But at the moment, there's a lot of focus on specialist users. And this perhaps 5 or 10 years ago, you needed to be a specialist user to work with all these NetCDF data and the interfaces as well. But the idea is to eventually move this down towards the general public. You're probably somewhere in the middle of this. Maybe you're a specialist user, maybe you're near towards the general public side. So if we have these standards, if we have fair data, we can gradually make the data more understandable over time through services that we can provide on the data. And I hope I've shown you some of this and encouraged you that this is now more accessible to you than it was, at least when I started at SIOS 6 years ago. And just a last point, if your data are not fair, we can't do anything more with this. The data will only ever be as accessible and readable and understandable as they were on the day that you published them.